Okay. Good afternoon, everyone, and welcome to today's XtraTracks lecture. It is a pleasure to introduce Professor Dr. Julian Kunkel from the Georg August University Göttingen and the GWDG. Professor Kunkel is an expert in high-performance computing, AI infrastructure, and large-scale data management. Since 2022, he has coordinated the KISSKI project, one of Germany's national AI service centers, focusing on secure and trustworthy AI solutions for healthcare and research. In today's talk, developing secure applications for health providers and research education, he will discuss how AI services and computing infrastructures can support health providers and researchers while meeting strict requirements for data security, privacy, and reliability. Please join me in welcoming Professor Dr. Julian Kunkel. Julian, the stage
Thank you
is
so
yours.
much, Soli, for the nice introduction. Yeah, I will talk a little bit about secure applications. And first, I will talk about KISSKI. This is the AI Service Center, a national service center funded by BMFTR. Then I will talk about a little bit about use cases, and we talk a little bit more about some secure offers that we have, a bit about community and so on, and the outlook. So what is the KISSKI AI Service Center? It's for sensitive and critical infrastructure. Of course, we cover aspects like security, data protection, and reliability. It's funded until the end of 2027. The services that we offer are certified according to ISO 27001, which is information security, and we work towards a C5 attestation. Yeah, our services are Germany-wide offered. In fact, you can use them via Hammerhai, the AI factory from the EU, in not only Germany, but Europe-wide. And we offer consulting, training, and infrastructures to end services. We also do a little bit of research to further improve our services. Our focus is on the medical sectors and the energy sectors, but we are open to other industries that fit into our scope. Yeah, in terms of our service portfolio, yeah, we cover the whole kind of life cycle from infrastructures. We have platforms. Yeah, so we have hardware. We have platforms on top of the hardware. We have dedicated solutions. We have consulting. We have training, and a little bit of development. No, we have AI solutions accessible via browsers and APIs that I will talk about. Hardware resources, we have some training platforms and inference platforms based on NVIDIA technology. We have also some alternative technologies. Here just some listing. Our trainings are offered via the GWDG Academy, for example, and linked online. Yeah, if you want to use our services, yeah, then you go to kisski.de web page, and there you can find here in German a screenshot our different services, and then you click on book. Then you enter a couple of information about the specific service you request, and then we kind of help you. Now, we have additionally initial consultation. We have monthly online introductions, like sessions dedicated for people that have want to learn more what we can offer and how to simply use these technologies. Now, you need to log in via the academic cloud, but anyone can get an access via academic cloud. It's as simple as getting access to a Google account. We also have some monthly community meetings that I will talk about. We manage our stuff professionally, for example, using tickets, support tickets. Yeah, we have a lot of different services that I will talk about real quick about them. Basically, let's start with our generative AI services that are highly requested, especially chat AI, so large language models, accessible via browser. We have API access. We also support commercial and open source models. We can do pricing, contracts, and so on. And a couple of links. Yeah. So let's look at the service a little bit more detail. Of course, we have a chatbot like chatai.academiccloud.de, which is like a typical chatbot that you can use. Of course, this is highest data privacy is what we look for. and information security. Now we have various ways to interact with the system and to share kind of what you have developed here, for example. Yeah, what can you do with it? What we would expect. Yeah, text processing, you can do attachments, including PDFs. Image and video processing can be triggered. Speech processing, input, output, reasoning models are supported. We have retrieval augmented generation, RAG models, which allows to use your own documents, very simple. We have tool support, MCP support, web search, and we have a constantly updated model catalog of open weight models and, of course, commercial models that you can inquire. Yeah, in terms of tools, yeah, with tools, you can talk with your models and you can, of course, invoke your model. Your large language model will make the choice to invoke a tool. Here is a set of tools that we, for example, offer: image generation, image modification, audio generation as an example. And we have ways to actually select these models from the options on the right side. Yeah, of course, you can use these tools. For example, here, create an audio from this text, and then you create an audio from this text. This is what tools do in large language models. You can also use it for OCR. Here is one of my invoices that I got, and I say, please give me the bill number, and then it extracts the bill number, which is useful for some kind of administrative tasks, right? And I just uploaded the image. Of course, you can do this with AI. With RAG, we have, in our case, we manage the vector databases for you. You can upload documents. We will just put in the information, which we call this Arcana, which is the RAG database that you want to use. And then it will use this as a context in the decision making. The large language model basically gets this knowledge and can use it. And therefore, you can increase the accuracy of the results, and you can use the sources that you may have. Now we have an interface to upload these files. For example, I could say I have here web pages that we wanted to upload, some documentation pages, so I upload them here, and then this is available and can be used out of the box with Chat AI as an example. Yeah, and of course you can upload two different types of files here as well. No, and then we can see here when we use this, it says reading this Arcana, and then it will, for example, use this knowledge. Now, if initially you don't get any knowledge because it doesn't know about it, and then you input the Arcana, which provides this additional knowledge, then this knowledge is used. We can see here it now knows about extra knowledge. Yeah, we have also a backend. We are not only a front-end that uses existing large language models, but we host open source models, and we host any kind of models that you wish we can openly host. Fine-tuned models, these LoRa adapters, all these kind of things they can taken into account, and they are hosted via the Scalable AI Accelerator, SAIA in short. And so you can use this to host your own services. We also have at the UMG, for example, in collaboration, a service for medical text recognition in place that is provided by an external company. Okay, yeah, this is ISO certified, and yeah, we can provide API keys to it. Yeah, we at the moment expanded with SAIA 2, which is something that is currently in place and replaces a lot of this functionality, and we heavily invest in this technology to host any kind of models. So you can use this AI accelerator not only to do large language models, but any kind of inference jobs that you need in a timely fashion. Yeah, from voice to images, whatever. Okay, we also have, speaking about voice, we also have voice AI, which can do transcription and translation. So audio files or live recordings can be transcribed into text, video subtitling. We had a Big Blue Button integration prototype. We now have a more alternative solution which can run anytime with any tool and does a seamless transcription in real time, and in the end it can produce a meeting summary. Yeah, we do this to enhance inclusivity and accessibility, as an example. Here's an example where you can upload files and do a transcription and modify your file and include it as a subtitle. Okay, we also host different models. Here's an example for protein AI, where you can put in the protein sequences. It's based on AlphaFold 2, basically, solution. Similarly, and then you can use this technology and you can create your inference for your protein sequence, and then do whatever kind of research you need to do with it. So it's not only that we have production cases for large language models, but others that I wanted to show. So let's talk a little bit about use cases that you can do. So examples, we have a lot of more prototypes. I could refer you to many prototypes that we've developed. Here is an example of AI support in patient care, writing a doctor's letter. So creating a patient's letter with explanations, because sometimes as patients it's difficult. You read a letter from the doctor, you don't understand what it means. You are positive, negative of what is positive good, is negative good. I have no clue, but I read it and I'm concerned. Then I call the doctor gets kind of a lot of questions. Maybe we can prevent these questions when we create patient's letters that describe you are negative, so that means you are free and healthy. Don't worry about this kind of thing. What does this mean? Here is an example, where of course you can use chatbots for many things. If you have more experienced, here's just very simple examples. And here is an example that the chatbot creates based on some kind of simplified issue. And we can see here the references provided. Here we had uploaded some Springer books, which is used as input, what means the specific types of skeletal information. Yeah, and then of course you could theoretically create a descriptive image and create voice output or something, and then it does create something. Of course, we have to be concerned about hallucinations, but that's what needs to be figured out when we try to implement such a prototype into production. We have to do, of course, user acceptance studies and more effort than just building a quick prototype in the afternoon. Good. Another example using AI in radiology. Here we have the case that we had prior reports, then we had diagnostics notes from the doctor, and from these prior reports plus the diagnostics notes, we basically derive a follow-up report from the patient. For example, it could say in the diagnostic note, again, patient is negative about the condition, but what conditions are we talking about is depending on the report and the kind of radiology analysis we are performing or screening. And in terms of classification, we see progress, stable, or regression, for example, of the conditions, but there's a lot of documentation burden, and of course, large language models and AI could help. So we helped. Here's the typical workflow that we talk about. You have this prior report from CT, and then you have a follow-up CT, and then diagnostics notes, which is a delta and assessment, and then you have a follow-up. And hopefully we can use a large language model to support this. And this is in a nutshell what we have been building as a prototype with guys from radiology. Here is some examples in terms of text. This is what the prior report, for example, diagnostics notes. I'm not doctor, so I don't go into details, but of course you can ask your questions later in the session if you have any. And then you have the follow-up generated by the AI with key aspects, and then you put in a template. Based on this template and this kind of progress, you want to create a document for these doctors, and of course for the patients, another one potentially. And then I could go much into detail what means what, but just to say that you see that this is something we have kind of implemented using the services that we had. And there is potential to include also voice transcription into this process. But of course, you can take also written notes depending on the stage of development that you are. note that what we do, at least in the KISSKI, our key principle is always we never replace anyone, doctor or anyone, including the radiologist. We see our solution as a supplementary tool, like Microsoft Word is also a tool that does not need certification. This tool should help you to get your job in terms of documentation faster done, that you have more time for patient care and things that matter to you, and no more time to spend with IT, which is something I'm, of course, more interested than you are probably. Yeah, so I always think about usability. Good. So yeah, here's an example. Yeah, we can do also some fine tuning. So this one is an example that we performed together with the researchers and doctors. So we had here 600,000 radiology reports. And then we did some fine tuning. I don't want to bother you with the details, but just to say, in the end, the fine tuning, of course, helped to improve the results such that you get better results for your use case, right? It's quite natural, and we can do this for many of the use cases. A key aspect is, of course, to have data available. Can be a challenge in healthcare, we know that. Especially in Germany, it is a challenge because of data privacy reasons. But I would say it actually pays off. It's one of the big challenges we must address. We must find ways to gather this data and make it accessible, that we can refine these kind of models and get better results, and not getting some external tools. Good. So this is another use case. Next, I want to talk a bit about secure HPC. This is addressing security. With secure HPC, we provide a platform to support processing of sensitive data. We want to retain the user's data ownership and data sovereignty. And basically, the data owner can decide on the data access permissions. We believe in a little bit in zero trust. So we assume everything can be compromised. So we must secure the data from attackers at all times, including from the administrators and so on. So yeah, we built a secure HPC service, and we have this one actually in production. I don't want to bother you exactly how it works, but basically the user holds the keys. We have also some key management service to support it, but in a nutshell, the user manages the keys. And yeah, we only trust the user's client because there the data is kind of produced. And then we have to have some kind of, in this case, a server where the user wants to progress and process the data. This one needs also be secured, but everything else is not considered trustworthy. Now, I don't want to go into detail how this works. You can ask these questions. I will explain to you. But what I wanted to point out is this is something actually we have in production since 24. Now, and it's used in an MIT use case to analyze and create these segmented brain images for MRIs, which aids the doctor in quicker grasping what is on these images. And this is actually production workflow with UMG. Secondly, a topic we work on, I want to present to you, is the trusted research environments. That is a project that we have in deployment now. We had it in development, and we still kind of move this forward, but we have prototypes built that we now put into production. And this is a secure environment for interactively analyzing sensitive data. So computation and analysis remains within the trusted research environment. These trusted research environments, they are sometimes also called SPEs, secure processing environments. I like trusted research environments better. They follow this 5SAFE framework from the UK office. And yeah, we kind of work on this topic. I could talk a little bit about this. What does it mean to be safe and how we actually implement this? Of course, we have here some means. I just want to read it because I like these concepts. Safe people, we need safe projects, safe settings, safe outputs, and safe data. I like this very much. I think this is a good concept. And of course, we have concepts to implement all of these in a fair fashion. So we called our solution the Göttinger Trusted Research Environment. In terms of technical features, we make a zero trust architecture, ensuring that administrators cannot break in. No single person can break in technically and gather the data, gain access, or compromise individual components. Yeah, there need to be I would say it's multiple people that work together to compromise our system. That's the way it is designed. So we have multi-factor authentication, collaborative work that we make. We have keys per file. Individual files are individually encrypted. A key aspect for us from the organization side was usability, because I like a lot usability. Yeah, while I'm a computer scientist, and I could tell you as a computer scientist, I of course like technique a lot. My own philosophy is that I know when you work on a different domain, like medical domain, you are not interested in computer scientists, and you are not interested in the technology. The technology should be a tool. You click, you understand it, it's easy to use, and then you can do what you should do, like caring for patients. You should not bother knowing all the nifty details, which you need to press Control F5 and whatever to get things working. This is what the system should do. That's why this is a really key to us. We make no client software needed. We use remote desktops via internet, web front ends. You can get graphical desktop environments. This is embedded in our HPC infrastructure that you get high performance. You can do machine learning with GPUs and whatnot. We have a lot of components in terms of stack, but I show you quickly how this works. And then you connect with the web browser. Yeah, here basically we have an example session on the top. This looks very technical because this bottom was on actually up to the user what they open, but we wanted to show that you can use this, you can get remote access. It's like you have from your laptop, you can basically connect to our system, and then you have suddenly a system available in this case which has 80 cores to compute. So we have here, of course, our systems. They are multi-processors. We have 2 sockets, 2 microprocessors, and each have, in this case, 40 cores used. And I think in terms of memory, oh yeah, we have 750 gigabytes of memory available for this user to do their job, which is, of course, more than you find in a typical laptop. Now, so I call this a little bit HPC out of the box. And then you can run graphical interfaces, including 3D acceleration, actually, that works, that you can use to visualize whatever you want to visualize. Yeah, we have here a web browser open as an example and some other thing. And this works inside your own browser. You have basically a remote desktop connection. Yeah, and then you can use, for example, one thing you can use is our Jupyter remote access to do analysis using Jupyter notebooks. And this then is all inside our Goethe, which means that the data that you use is encrypted and safe according to this 5 safes. Yeah. Okay, I'm not talking about the limitations. I talked a lot about these. What we are also working on is to integrate the Göttinger data catalog, that you have it simpler, that you can search. For example, I need certain, you don't have to think about file names anymore, but you can say I need all the females that have a birthday between 90 and 99, and then I need a list of 20 people that match this criterion, and then you do some kind of analysis. Of course, we have also ingestion pipelines for parallel ingestion that includes when you upload from your client, already the data is encrypted in your browser when it is uploaded. Of course, we have also dedicated uploader systems, and then it is in the system, and then you can use it. By the way, getting something out from a trusted research environment is a difficult process because that is the purpose. Okay, that's one of the purposes of the trusted research environments is safe outputs. No? So that there needs to be some approval process, multiple people need to approve, and it needs to be clear that you cannot do re-identification of individuals of the data that you kind of egress. For example, you can get fancy pictures, yeah, you can get some kind of analysis out, but you should not be able to get about me, my private data out as a patient, because that would be a violation to GDPR and so on. That is kind of part what we do with the trusted research environment. Overall, I strongly believe in open ecosystems. We should not have vendor lock-in. We should have affordable healthcare. We do this, we rely heavily on open source. We develop open source solutions. We make these things available with endpoints that are, for example, OpenAI compatible endpoints. We believe in standards, system standards that should be used, such that you can replace individual components or vendors, providers, and developers, including us. No? What we develop can also be self-hosted most of the time. And we integrate also with commercial services because we, of course, recognize that there are cases when you need to use commercial software. Yeah? For example, we have in the Goethe, just as an example, yes, there is software that can run inside, that you can provide, that you can choose, that you can also provide to us under proper license management, that you can use then inside your trusted research environment, just as an example. Okay, yeah, so what we do else, I think open governance is important for key components. We cannot guarantee this for every component because it's a lot of effort, but for a chat AI, our large language model system and core system that we use in our ecosystem, we have even an open governance. That means people can decide on features that will be coming, and we will help to implement them. And sometimes the community even contributes to it, which is even greater. Yeah, in terms of more to community, we have a monthly chat AI community meeting. Then we have GU8, a monthly meeting for AI developers. We have, I think here's something messed up a little bit. We have AI communities. In a matrix channel, we have mailing lists, additional mailing lists, and so on. And you can get information, you can get updates when we find this important. I think it's very important in the era of AI that we are in now, that we have ways to exchange our information. We need to work together. We need to build communities, users. We need to build communities of providers, service providers, and those that are maybe two roles, because time is running out. AI is really, really accelerating. And yeah, anyway, more to this. Yeah, in terms of contracts, we can, of course, do contracts. Our official service is up to what we call in Niedersachsen, in Lower Saxony, data privacy level C. But health data is privacy D. We can do this, but then we need to have a discussion with your data privacy officer, of course, because you can never just go. It is use case specific, but every time we had this discussion, we can resolve the matter and find a solution. For you, for example, using SECO HPC or using the trusted research environments. And we have basically now also a chat AI service components that can do up to level D. It's just not our official offer because it comes with extra cost for us and effort. So we have this only in pilot with selected partners. Just to mention that we work on this C5 certificate, which is needed for long-term provisioning of the services in health as a healthcare. Good. Yeah, we can talk about contracts, but I don't want to go into this so much, but it's possible. And I think I spent my half an hour because I wanted to give you some time to discuss. From my summary, I think AI is in fact a deluge. It comes to us like a blizzard. It's an earthquake. It revolutionizes everything, and not only our work environment, programming, for example, for me, but also in medicine, everything has to adjust. I think ethically it is needed to make this adjustment, because if we can help patients by providing more time with their healthcare, focusing on things and getting better results potentially using these kind of tools, I think we should do it. So we should be in the game, especially in Germany. but it's difficult and challenging. So I recognize these challenges from the legal side. In KISSKI, we work towards general applicable AI services. We have a lot. We have chatbots. We can do workflows. And secure environments. I talked a little bit about data sharing and research. Consulting and training is also possible. We have a lot of production services that you can use. I didn't mention this, but our chat AI, for example, is used by more than 100,000 users. And in the API is used, we estimate, around 1 million users. And you can use this to evaluate prototypes. I would also recognize my experience in AI is, especially in this field, doing a quick prototype often can be done quickly. Then we see using AI, for example, this is, yeah, it's doable, right? It makes sense. We can use this to create patient letters and so on and so forth. Then to bring it into production, it's at least 10x more effort. You don't only want to bring something into production, but you need, for user acceptance, for example, not only 80% or 60% accuracy, but you need maybe 95. It needs to be in the ballpark that the human benefit is better than correcting the mistakes the AI, for example, does. And this requires some fine-tuning, and it requires you from your side as well. Yeah, I'd say we, GWDG and KISSKI and the whole consortium here that I kind of represent, we are very flexible and open partners. If you have specific needs, if you need discussions, we can often help a little bit without actually talking about money initially. Of course, if we talk about a lot of investment from us, months and months of development, this is something we cannot do for free, but a couple of days we can usually spend as part of this project, which I think I wanted to say thanks to BMFTR to fund KISSKI, because that is the purpose of this project, is to kind of help people to see the potentials of AI, the potentials and of course limitations, but we should be on that side and explore the possibilities and be part of the game. And now I look forward to your any questions that you may have. Of course, you can ask me critical questions too.
So thanks a lot, Julian, for your nice talk. So do we have any kind of questions here in the room from the audiences? Also some in the chat, for example, if you don't want to talk with us.
It's one from Stefan Lenz, I think.
Yeah, I'm not sure. I could not see how to raise the hand. But yeah, thank you for this introduction into this service. I'm personally also like an IT guy. So my question would be, like, if you wanted to use these services, of course, there are these legal issues that you need to clarify whether you can use your data with it. But then the other question is how, like, is there some cost for, I don't know, if you, for example, you want to train a model, you have some use case, you don't necessarily maybe require like assistance from you in terms of manpower, but of course then some requirements in compute. And how is this handled? So is it all covered in your initial funding, or do you need some extra funding, or if you need to plan to use it, then do you need to apply for some money to use it? So that would be my question.
Okay, so the quick answer is the initial contact is for free. Yeah, it depends a lot on your resource usage. Generally, we are also free for pilot projects. No, but if you need 100,000, let's say, of GPU hours, there are certain limitations that we cannot provide. But for most users, it's really free. And it is for this kind of exploratory work, especially for KMUs. You mentioned that you are also in the IT business, Mr. Lenz. No, I'm not sure if you are from a company. Can you not, maybe, or not? I don't know.
No, I'm from a university hospital in Mainz.
Yeah, okay, Mainz. Okay, university is also fine. University is no problem at all. We don't bill anything. Yeah, we basically go to the service catalog, and then you in your case, you said, okay, I know what I'm doing. I don't need any kind of training, support, or whatever. We have actually documentation as well. Then I say, I just need compute resources for training. Great. You click here. Okay, what you need. We have here, 35 nodes, GPU nodes available. Okay, I think this is the right service I need. Great. Then I click on book. I need to log in with academic ID. Is done. Then I say a little bit about myself. Yeah, web page and so on. We need to have KPIs. Yeah, but you can keep this short. Okay, I'm not saying usually this goes in half an hour is done. More often even faster. Here, add a little bit about your project. So you could say, I want to do fine tuning of this and this model for medical reasons. A paragraph or something, I probably be fine. This is the thing I need. I think I need whatever 5,000 GPU hours is what I want. There you go. And then do I have critical data regards to GDPR or ISO, whatever? You need to say, is this, anything confidential, whatnot? And then you go confirm our things, and then we have it in the ticket. You get quickly some answer, most of the time within 48 hours. It rarely happens that we don't grant anything. Yeah, it very rarely. We have done, I don't want to lie, I mean, we have processed more than 5,000 tickets in the last year alone. That was the numbers. This includes across our services. It's just an example. Then, and of course, you can start with something. You can play with this. And what sometimes happens is when you do your pilot study, it works. People come then back, for example, and say, now I have trained my LoRa adapter or something for fine tuning. Could you please host this? We have the inference platform as well, and we can host it. It is like this. We are working into getting this more into a self-service. You can actually upload the LoRa adapter directly, but at the moment you would then click here and here in this case we have no fancy booking, but you would click on support and then kind of send us the email. This is what you need. Okay. But for most of the services, we actually have this fancy booking page, and we have a lot of services that you can find here. That we can help you with. And for everyone, we certainly do a free consultation. This is what you have, this is your need, this is how we could potentially help you. Let's see if we can actually find some professional here person from tech that can help you to do the job. Yeah, that's our mission. Yes, we are support guides with this project. It's to help AI in Germany.
Yeah, I think we have a second question from Herr Krieger Manfred.
Where is it?
Sorry, my mic was out. One question is, in the beginning, you talked a lot of large language models. Do you use any, I would say, self-developed large language model, a so-called foundation model, or are all the models, the language models you use are from other research or industry groups?
Yes, so we have at the moment only open weight models that are not trained by us, but this includes the European ones, like Mistral, Teuken as an example. And fine-tuning is something we can offer though, of these models. So adaptations of these models we can easily host. The thing is, training a foundation model, if you want to do it in a high quality level, you can easily spend millions of euros in GPU time, not once you have the data sets. And of course, we cannot have millions of euros in just one shot, one training of something. So that is not our role. But providing these and doing this fine-tuning, which can usually take in a couple of days, you can get your refined models, is something we offer. We try to get as many people, support as many people. But of course, if you had now a lot of data sets where it would make sense to do fine-tuning, we can find and help you, because we are also involved with the national levels and the NHR centers, for example. They can do this kind of fine-tuning. They have more GPU resources. But I would be very cautious when I talk about a foundation model in Germany, because the legal copyright situation is a nightmare here.
Okay, thank you.
Okay.
So if we don't have another question, perhaps I may raise one question. So what you showed us right now are a lot of use cases, a lot of influence and focus on, I would say, technical parts. So I would assume there's also a big need for training of some kind of users and how to use AI in the end. So is there something in your queue right now what you can offer here for our audiences, for example, in the healthcare sector?
Yes, so we have various trainings that we provide, for example, in the GWDG Academy. We have also some donated trainings from the partners that are part of the KISSKI consortium that are not, you don't find this here, but in others. But this is the one that we develop as an example. And here you see, for example, data pools for scientific data sharing, and we can, let's check overview AI services. Yeah, there's always something coming up. So here we have AI for administration. We have deep learning bootcamp, right? AlphaFold, effective utilize AI tools in research. We have a huge set of slides and trainers. We have actually 3 trainers that can do trainings and offer trainings for you. If you have or if you have needs, and they are not directly listed here, we can always talk if we can find something that we can scrape off what we have already as training. Of course, we have an AI competence training. Is not listed here. We have some online videos, MOOC kind of style of things. We also interact with the other AI service centers to provide you training. I think training is, in fact, really crucial to get people on board with AI. And I could probably employ 10 more people in training easily. But if you need something, we try to accompany it. No?
Okay, thanks a lot. Do we have other questions from the audience?
I have a little question too. Is this how works when there are many institutions, different institutions working in a project? They need to write first together and act like a project, or should each institution have the data and so on as a contract for each institution, or there is a contract for one project with all institutions? This is not clear for me.
The word contract is a difficult one. So let's say the easiest way to do it. When you recommend and you request here some resources, yeah, I want to do this inference training. Let's take this example, okay? I do data analysis or something, or I work on this trusted research environment. You do one request, and then you would probably put down, okay, in the description, yeah, I work together with a couple of folks. Then what we have a portal. You are the PI then, you are the ultimately responsible person, but then you can add into our portal, we have documentation about this, very simple. You invite other people to your project, and then they will be invited, and then they have access to the same data as you have. Okay, that is the way it kind of works. So that is simple. Now the question is, do you need contracts? Okay, if you work under our AGBs or generic rules and regulation stuff, okay, all is fine. If you have special needs, like you say, okay, we have here non-anonymized data, we need the highest data protection, then we have to have a chat with your data privacy officer, because we have to then show this is our architecture. We have to convince him that for this use case, our technical organizational measures are sufficient. If that is all sorted, then we can probably make a contract, and we can talk about, under these conditions, we make the system available. But once we get to that point, we have to clearly think, is there, depending on the effort we have to do, is there some financial compensation necessary? Yeah, that is a key question that needs to be asked. Now, it depends a lot on the case-by-case basis. Yeah, we always try to be free and so on, but if there is a lot of requirements, which we of course try to honor for you as well, then at some point it cannot be free anymore. That is the nature of, I'd say, life. No, just to be on the safe side, that we have a good understanding. That's why I like the term compensation here, because truly it is a compensation, but the core things would be free. No, but we have only limited resources to do these contracts, especially when we have to consult external peers and so on. Yeah, we try to make everything as the blueprints, but it can be challenging in times.
Okay, thanks.
Okay, I don't see any more questions, but then I would just add one more thought. In general, I think in terms of sovereignty, yeah, our own sovereignty, we need to be part of a solution. It does in this health area. What I see a lot, we see now people coming in that present a solution, best and proprietary commercial solution that has no proper input and output definition, no clear interfaces and so on. They just say they have the solution for you. And in health, of course, solutions costs always a lot. Yeah, and I fear a lot, and I've seen that in this AI area, yeah, this is so rapidly evolving, and I think we need to build our own competencies. So we must be part of this kind of development. So my recommendation is not to buy something off the shelf, but rather be part of the solution to develop these things, to be part of the stakeholders that influence these solutions, and make sure that these solutions are open and truly help our patients in Germany and throughout Europe and so on, and that healthcare remains, affordable. That is what I wanted to say to conclude basically this, and I hope you guys have a great remaining sessions in XtraTracks. Yeah, back to you, Stefan, I guess.
Yeah, thanks a lot. Perhaps I just have one last question here from my side, if no one else want to step forward. In regards of AI and medical aspects, I would think, well, we very fastly come up into the regulatory part. So like, okay, what kind of support do you give for those people who want to just rapidly prototype here some kind of AI for medical aspects, and then arise those questions or support those questions? Will I be a medical device in the end, or what kind of steps do we have to take here? So what kind of role do you have here in KISSKI about this?
Very good. I think this is a key question. For the continuation of KISSKI, we have currently, starting in the end of the year, we have specifically requested a couple of more support staff, 2 people to support kind of this regulatory aspect, 1 for medical device development, that we actually can support it. At the moment, our support is limited, I would say. That's why we have requested this extension of the project, specifically for these aspects. It is absolutely necessary what you say. From my own perspective, okay, and I'm recorded, but I see there 2 aspects. Number 1, I would strongly always try not to be a medical device, so that the people that are in the room that investigate this technology, you ask the right question, you look at this technology and you say, this is not a medical device. Like Microsoft Word is not a medical software, right? So this can be supported, for example, by having the human in the loop. This thing does never make any decisions, because then we are in high critical in the EU Act, which we actually look at. This is where we have good experience. We have very good experience with data privacy, and we have very good experience with the AI and EU Act. Yeah, this is we have very good experience with these two. We are not very good yet at this medical device thing, because I always try, and we always try to not be a medical device. Yeah. Okay. So, and there are various ways. And the good thing is, when you do these explorations, you usually can come around this, because you would never install something in a ER room that automatically does things and, you know, is directly in patient contact. It can always be considered that the AI supports you and you explore it in a more research-friendly ecosystem. Okay, so somehow in the I would always put these things into this research kind of perspective to see what is doable, and I think there is a lot doable. Yeah, and yeah, we managed to get some things into production, but in terms of logic, I can tell you also, it's more like this: you spend 3 months with the prototype, great, it does work, you are happy, and then you spend 9 months to sort out all the regulatory things to actually get it into production. It's not that you spend the whole 9 months working, but I mean, it takes 9 months to sort them out step by step and have repeated meetings with the people. That is my experience with this. So it is the hard part. So if you want to get something out, you need to be in an environment where everyone agrees, okay, is no risk to the patients, it's no medical device. Yeah, we are more in a research environment to explore these things. And then you talk about the next steps. And I think that's the right way to go, to be very agile. It is not helpful to wait years and years until magically there comes a software that does it. The same is not helpful to wait until the software is 100% done, and then we never explored this, we put it into production. We have to kind of bridge this gap.
Yeah, thanks a lot for your thoughts here. So do we have other questions? So we just have a few more minutes, if you like.
In the question and answers part of this presentation side is one question: is there any strategy to provide MCP connectivity for KISSKI?
Yes, we have this. Yeah, so if I go, oh, I'm not sure, I think actually you can see I used it to translate the slides for you guys, but great. So we have here tools, and then you can put here MCP, and then I could put here a list of MCP servers with comma, and then they would be used as part of the tool environment. That is basically what we do here. And of course, we have the similarly in the back end. So if you just use our API, you can also use it to connect the MCP servers.
Thank you.
I think we have a second question in the question and answers.
Yeah, I can ask it myself. Yeah, of course. I'm a doctor, physician, and I'm trying to translate like clinical decision support algorithms in the clinical use. Not only AI-based, also some rule-based things, but like for your services, I have the question, besides from the regulatory part and the necessary documentation, how is it possible to reach scientific reproducibility, to be able to reproduce your findings and get the same if you use it on medical questions, on medical inference, especially if you are kind of dependent on foundation models which can be changed like any day by the yeah by the big producers of these models.
Yeah, thank you. I mean, I think this is a really important question. In my background, I come from the climate and weather science, and they are even worse in that sense that they said for many decades they need bit reproducibility of the results. Okay, and I'm saying this because it means I have a little bit of experience. But now to address this, I think the question in itself is somehow a little bit wrong. Okay, getting scientific reproducibility doesn't mean necessarily that the underlying large language model or the underlying foundation model, whatever technology I have, produces the exact bit identical result as an input. It just means I, as a researcher, come to the same conclusion. Why I'm saying this is because if you ask the doctors, right, and you would ask them, here is a MRT, what do you see? And I'm not sure, but what you think about this. But if I take the exactly same doctor, 100 days, and I give him exactly the same input image, would they give you literally the exact wording of every character and things that they see? I am not sure about this, okay? I rather think the answer is no. And this is similar here. But what we need to guarantee is that we understand how this came to the conclusion. What is the conclusion? What it derived? That we can assess it, that we understand the uncertainty attached to it, and that we can automate this process. So, for example, what we do when we talk about large language models assessment, you can use large language models in harnesses to assess the output of large language models. Something like, here is our example output, here is example B. Is this basically equivalent, right? It's like you ask two human people, here are two texts, do they describe the same thing? The answer could be, oh, in this case, both talk about the heart condition, but in this case, the guy talks about some shades, which could be cancer. In the other case, it misses this, right? So this is a clear difference. And you can use this kind of harnesses, and you need to automatize this. And then I would agree, this makes sense. And the cool thing about this is you can use it for your regression, your development as well. Because what is true is, if you are later asked, right, in 10 years, there comes a patient and says, how did you come to this conclusion, right? Imagine the doctor would say, of course, I remember exactly this case, right? And this was exactly these conditions. No, the guy would go into these documents, would read his documents, and come to a conclusion probably. And this is, I think, a similar thing that I would say we should transfer to the systems here. And this is the only thing we can do, because we cannot possibly recreate the system environment of the large language model. We cannot necessarily recreate the initialization vector, the random factors, you know, exactly everything. And because of that, I would say we need to find better ways with reproducibility, which is more on the science, on the high level side. And then we are also safe because we understand what the system does. I hope that helped.
Yeah, I think your answer really helped. It was most on the point, but I definitely not meant the reproducibility of one single result, but the reproducibility of the performance. Like if you put 1,000 patients or the data of 1,000 patients in the model or in the tool, would it get the similar sensitivity and specificity for a certain question, or would a change in the foundation model like put the performance down to a cutoff where it is not acceptable anymore?
I think not. I think the answer is what you are saying is there will be boundary cases. Yeah, okay, if I put 1,000 in,
all the time.
Let's say for 800, you put these 1,000 things 100 times in, let's say, with the same with different initializations, with different conditions. For 800, hopefully the result is always the same, right? Like, for example, I have cancer, no cancer, whatever question is you are interested in. For 200, maybe you get sometimes slightly different answers. And maybe some of them are actually wrong sometimes, right? It's like I would ask you, what do you see? Person says, next time person is sick. Yeah, maybe, but that's, in my experience, is usually when you ask the right questions, a small number. And those things are maybe the more ambivalent ones. And of course, exactly as you said, you need to investigate this behavior that you can judge, because it should not be by random chance, right? And I think it is really a good task to do, and a very important one. But for me, it's the same, right? If I give to 10 doctors some case that is boundary, some guys would actually say, and women, of course, would probably say, okay, I cannot make a judgment. Maybe some would say this is healthy, some would say no, right? There are probably those kind of boundary cases. And then you need to be aware that there is this boundary case. Maybe, in fact, that is a good thing. So maybe we should do this kind of studies. We put different large language models, and people do this, right? This kind of sensitivity studies. You put one model and 10 times or 100 times it in, and then you have some confidence, right, into the result that this is making sense. But yes, ultimately, these things, they are not better much than humans are, because they are trained from data humans produce. But what we can see from a lot of literature, I'd say they can be as good in many cases as doctors, for example, or people or experts. Me for coding in many cases. But I always want, me personally, I always want that the doctor is there and they look at this, right? They form their own opinion, then they look at this. Oh, is there something in the bottom right? I may have, oh no, it's not, right? The LLM says something or so. So I think, yeah, we have to find out. I hope we will never go into this automatic diagnostics world where everything is handled by technology that might be flawed. I think the expert needs to be there, but the expert time is valuable. So we need to invest the time in which counts best.
Yeah, thank you.
Okay, cool.
Perhaps I can just point out one more question from my side. So we talked a lot about right now about all those fancy stuff you can do here with KISSKI and all those infrastructure. So I would assume that the requests from the start of this project till now just arised in the explanatory way. So I would like to know a bit more about your perspective. I mean, when the whole funding is ended, so in years, I don't know, what will happen then? I mean, will it be like a community-driven way, or will it be taken as a company in the end, or how will this infrastructure be being used in the future, especially when the requests are rising even more, so like even more than today?
Yes, I mean, we have as part of these projects that we have, and I showed you until 27, we have one project. We have one project of KISSKI that we are that starts end of the year, that goes to 29. Yeah, of course, sustainability is something that we need to consider, and business cases. Yeah, we are asked at some point to produce a consortium, a solution like this KISSKI AI Service Center, that it could survive this initial funding period that we now experience. And we, in fact, started this already, and we have discussions with people. So when you have more to do than a pilot project, when you are not from the university, and we have some KMUs, quite some KMUs that we serve, and they want, and of course they need also some regulatory things. They want contracts, SLAs, they want kind of some boundary to provide this in a production service. Then they pay us, and from this payment, we kind of add, for example, new GPU nodes. And this is kind of the thing that we just started. I mean, we started discussion a year ago, but now we actually start this process to actually commercialize parts of it. The word commercialize is maybe not right, but to sustain it, to ensure that it's sustained. And GWDG, as an example, it's a public-driven company. Yeah, we are, as GWDG, a public-driven company that is non-profit. So everything that comes in is used to kind of for the mission of GWDG, which is to support research, education, and of course to sustain kind of such ecosystems for Germany, so to speak, right? So that's why I have some trust in this kind of construction, because it prevents us to be sold out to, for example, US companies and other external stakeholders that would grab us if we do a very good shot here. We have a very good products, which I say we have good products, yeah. Then why wouldn't they pay for us as a startup or anything, right? And take
absolutely sure. So the one question I think is here. So right now you have a really tough time, I guess. No, I mean, especially when it comes to the rising costs, especially in the hardware sector. So right now it is kind of hard to show up like, okay, everything can be paid in these regards what you have right now, and don't I mean, in the end, it is not only hardware, but it's also human resources you put in here to have this kind of support in the end and to give everything what you have here. So I guess it is not the most easy way to go at the moment.
Yes, thank you so much for this. Yeah, can be true. I'd say we are in some things very efficient, like the TREs and so on. There are bigger consortia and projects that try to build something like this. Yeah, we build some of these things. So I think working smart and working with you guys, for example, as partners, can sometimes lead to surprisingly efficient solutions that then can help to shape the mark and make this, like I said, in the long term cheaper for the whole healthcare sector. No, yeah. Thank you so much for this longer discussion.
Yeah, thanks a lot, Julian, for your great talk here.
Yeah.
So if we have a last question, otherwise I would think, Zuli, you may just close the session here.
Yes, thank you very much, Julian. This was a very important talk, and is for every people, and knowing how is KISSKI working, the future, and how we can all use it for research and for education too. And thank you very much.
Bye.